Okay. Okay, so you're using two calculator functions, NormalCDF and InvNorm. It can get tricky to know which one to use when. So I'm going to recap what we know about these two functions. The NormalCDF function on the calculator takes z-scores as inputs and gives you area as an output. The area it outputs is always between 0 and 1. Now that should make sense to you because the entire bell curve is 100%. So you're never going to have an area that's greater than 100%. And expressed as a decimal, it will never be greater than 1. So you'll enter a z-score in the form lower z-score, lower z-score for the lower limit, upper z-score for the upper limit. You'll put in a mean and standard deviation of 0 and 1, and then NormalCDF will give you an area. We can interpret this area as the probability between the two input z-scores. And we're going to look at more examples where we answer probability questions that can be solved with NormalCDF. On the other hand, the InvNorm function on the calculator reverses the process. Instead of taking in z-scores and giving us out area, it takes in area and gives us out a z-score. So it takes in an area, but it has to be area to the left, and it outputs the z-score that corresponds to that area. So InvNorm with area 0.25 gives us the z-score that cuts off the bottom 25% of all the data values. So in a bell curve, the bottom 25% is that left tail. The bottom 25% of the left side of the bell curve would be shaded in, and you'd find the z-score that cuts off that area. So what would an InvNorm with an area to the left of 0.50 be? So if you used it without putting this into your calculator, just think, what's the z-score that cuts off the bottom 50% of area? And you should recognize that that z-score is the very center of the distribution, which is a z of 0.